The complete history of automated cleaning robots is a story that weaves together imagination, science, engineering breakthroughs, and the constant human desire to make life easier. Long before the term robot vacuum became common in households, the concept of machines that could perform domestic chores without direct human effort was already taking root in the minds of inventors and storytellers. In ancient myths and early science fiction, writers envisioned mechanical servants tirelessly sweeping floors or polishing furniture. While these visions were more fantasy than engineering at the time, they laid the groundwork for a cultural fascination with automation in the home. By the mid-20th century, the rapid post-war advancement of electronics and mechanical engineering began to make such dreams more plausible. The idea that robots could not only assist in factories, but also enter the private sphere to perform mundane tasks became increasingly attractive to both researchers and consumers. The 1960s and 1970s saw the first tentative steps toward domestic automation. Engineers were experimenting with primitive mobile machines, many of them built in university labs that could navigate a room, detect obstacles, and perform simple functions. These early prototypes were bulky, slow, and expensive, often requiring wired connections to a central computer. While they were far from market-ready, they proved a point. Mobility and automation could coexist in a domestic setting. During this period, vacuum cleaners themselves were already undergoing major technological changes, with lighter designs, stronger suction, and improved dust filtration systems. However, the leap from better vacuum to self-operating vacuum was still a significant one. In the 1980s, a new wave of research emerged in the fields of robotics and artificial intelligence. The Japanese electronics industry, in particular, became a hotbed for robotic experimentation, driven by cultural openness to robotics, as well as government and corporate investment in automation. Engineers began integrating sensors, basic microprocessors, and motorized wheels into small devices that could, in theory, navigate a floor space. Still, the hardware limitations of the time meant these machines lacked the intelligence, battery life, and mapping capability needed for reliable autonomous cleaning. The turning point came in the 1990s as advances in microprocessors, battery technology, and compact sensors created new possibilities. Companies began to explore how these technologies could be packaged into consumer-friendly cleaning devices. In 1996, Electrolux introduced the Trilobite, widely regarded as the first commercially available robotic vacuum cleaner. It used ultrasonic sensors to detect obstacles and operated independently once activated. Although expensive and somewhat limited in cleaning ability, the Trilobite was a milestone. It proved that an automated cleaning robot could exist as a consumer product. The novelty drew attention, but the market for such devices was still niche. The true mainstream breakthrough arrived in 2002 when iRobot launched the Roomba. The Roomba's design was compact, circular, and far more affordable than previous attempts. It used a combination of bump sensors, infrared detection, and a simple algorithm to cover floor space effectively. Instead of mapping rooms in detail, the early Roomba models relied on randomized movement patterns that, surprisingly, did a decent job of cleaning most areas. Its affordability, ease of use, and distinctive personality — it beeped, spun, and looked busy — made it a cultural phenomenon. Over time, iRobot released improved models with stronger suction, better battery life, and smarter navigation. The mid-2000s saw an explosion of competitors entering the market, from both established appliance brands and tech startups. Companies like Nieto Robotics introduced laser-based navigation systems that allowed cleaning robots to map rooms more efficiently and clean in straight lines rather than random patterns. These systems marked a significant step toward the smart robots we see today. Around the same time, improvements in lithium-ion batteries allowed for longer cleaning times and shorter recharging cycles. while brush designs became more sophisticated to better handle pet hair, dust, and debris. By the 2010s, the robotic cleaning industry had diversified well beyond vacuuming. Automated mopping robots, window cleaning robots, and even pool cleaning robots entered the consumer market. Advances in computer vision and AI meant that cleaning robots could now recognize obstacles, avoid stairs, and even distinguish between different types of floor surfaces. Some models could automatically return to charging docks, resume cleaning where they left off, and empty their own dustbins into larger containers, reducing the need for human intervention to just occasional maintenance. The integration of smart home technology became another turning point. As voice assistants like Amazon Alexa and Google Assistant became popular, cleaning robots gained the ability to respond to voice commands. Mobile apps allowed users to schedule cleanings, track progress in real time, and view digital maps of their homes. Machine learning enabled robots to adapt to furniture layouts, remember high traffic areas, and adjust cleaning intensity based on dirt detection. These advances made the robots more efficient, user-friendly, and capable of blending seamlessly into daily life. The COVID-19 pandemic in 2020 further accelerated demand for automated cleaning solutions. With people spending more time at home, there was a heightened awareness of cleanliness and a desire to reduce daily chores. Manufacturers responded with new models that offered antimicrobial brushes, HEPA-grade filtration for capturing microscopic particles, and quieter operation for working from home environments. In recent years, we've entered what could be called the premium intelligence phase of cleaning robots. Devices now use LiDAR, stereo cameras, and even 3D sensors to create precise maps and navigate complex spaces with remarkable accuracy. Some high-end models, such as those from Robotic, Ecovacs, and Dyson, combine vacuuming and mopping in one unit, automatically adjusting their cleaning method as they move from hardwood to carpet. AI-driven obstacle recognition can identify and avoid cables, socks, and even pet waste, something early robots famously failed at. The future promises even greater integration and autonomy. Engineers are exploring robotic systems that can work in teams, with smaller robots tackling tight spaces and larger ones handling open areas. Self-cleaning water tanks for mopping robots, advanced dirt detection sensors, and integration with home security systems are already in development. There is also a push toward sustainability, with robots made from recycled materials and designed for energy efficiency. Beyond technical innovation, automated cleaning robots have had a cultural impact similar to other major household technologies. They've inspired memes, social media trends, such as pets riding Roombas, and even academic studies on human-robot interaction. They represent not just a convenience, but also a shift in how we relate to household labor. By outsourcing one of the most repetitive chores to a machine, we freed up more time for leisure, work, and family, while also sparking debates about dependence on automation. From the earliest science fiction dreams to the precise, AI-powered machines now available, the history of automated cleaning robots is a testament to how quickly technology can evolve when there is both a practical need and consumer enthusiasm. These devices have gone from rare curiosities to household staples in less than 3 decades, and their evolution is far from over. In the coming years, we can expect them to become even smarter, more versatile, and more deeply integrated into the fabric of our homes, continuing the centuries-old human quest to make daily life a little easier